Then we'll add to that alpha times beta over beta minus alpha T2. And then there was a T2 beside the T1, so let's not forget that. Next, we'll have 1/2 beta T2 squared. Nothing to substitute there. Next, we'll have minus beta. Then we're going to substitute again beta over beta minus alpha T2 times the T2 that was beside the T1. And then we're going to add to that, we've got one more term. That's the 1/2 beta, and then T1 squared would be beta over beta minus alpha T2, and that quantity is squared. Okay, so now let's work all of these out, and we'll try to keep the beta minus alphas in a nice position here. S equals, and let's see. To clean things up, let's factor out, well, let's go ahead and square things out first. We'll do the factor out in the next term. 1/2, here we'll have alpha beta squared T2 squared over beta minus alpha squared plus alpha beta T2 squared over beta minus alpha, and I'll put that in parentheses to set it off. Okay, and then the third term, 1/2 beta T2 squared plus, or excuse me, minus, the next term has a beta squared T2 squared over a beta minus alpha. And finally, we've got a plus 1/2 beta to the third T2 squared over beta minus alpha squared. All right. And let's see. Now, it's simply a matter of combining, and let's see, I forgot my 2 on this T2 squared. Okay, combining all the terms and solving for T2. Okay. Now, notice that every term on the right has T2 in it, T2 squared actually. So let's factor that out. S is equal to, and let's put it this way, I'll just put the alpha beta squared over 2 beta minus alpha squared plus the alpha beta over beta minus alpha. I'll leave a little room here. Plus 1/2 beta minus beta squared over beta minus alpha. And finally, plus 1/2 beta to the third over beta minus alpha squared. And that entire quantity is multiplied by t squared. Now, of course, we can, at this point, divide both sides by the quantity in square brackets, but of course we'd want to clean that up first. And to do that, we will seek to get a common denominator here. And so our common denominator would involve a 2 beta minus alpha squared. So here I'll need to multiply by beta minus alpha on top and bottom. On the next one, I've already got the 2, but I'll need to multiply by beta minus alpha squared. Beta minus alpha squared in numerator and the denominator. Here I will need a 2 and a beta minus alpha, numerator and denominator, beta with alpha. Okay, so let's see if this will help us simplify these things. Notice all of the terms now have the common denominator, so we only need to write that once. 2 beta minus alpha squared. Okay, and our t2 squared will still be out here at the end. Okay, so here we'll have alpha beta squared plus 2 alpha beta squared minus 2 alpha squared beta plus, here we'll have 3 terms, beta to the third minus 2 alpha beta squared plus beta alpha squared, or alpha squared beta. All right, minus 2 beta to the third plus 2 alpha beta squared, and finally plus beta to the third. All right, so now we're ready to combine our like terms. And again, lots of algebra. Let's notice here's alpha beta squared, here's an alpha beta squared, here's an alpha beta squared, and here's another one. Okay, so those will be combined. We've got an alpha squared beta here, the alpha squared beta here, and then we have under this one and this one are our 2 beta to the third terms. Well, actually 3 beta to the third terms. Okay, so those 3 will be combined. S equals square bracket. And so if we count up the alpha beta squares, we get, let's see, we've got 1 and 2, and minus 2, be back to 1, and plus 2 would be 3 alpha beta squared. And then if we go to the alpha squared beta terms, we have a minus 2 and a plus 1. So that leaves us, let's say that's, yes, minus 2 and plus 1. So that would be minus 1 alpha squared beta. And that's all we have in the in the numerator, because the beta squares we have, beta cubes, we have a positive 1, a negative 2, and a positive 1, so those come out to be 0, those cancel. 2 beta minus alpha squared. And this quantity is times t squared. Now t2 squared. Now to solve for t2, we'll simply multiply both sides by the reciprocal of that fraction in the square brackets, and that gives us that t2 squared is equal to s times the 2 beta minus alpha squared over 3 alpha beta squared minus alpha squared beta. And let me double check that. Okay, we'll need to solve for t by taking the square root of this. Okay. And actually there are two possible solutions, positive or negative square root of this. We want to come out with a solution for t that is positive, so make sure that the expression you get will give a positive number, otherwise you need to take the negative of it. Now we can move outside the square root the beta minus alpha. Okay, and so let's see, I should really put this plus or minus out here. Okay, and this plus or minus right here, because you will see when we get the square root of this, we'll get 2 times s over the 3 alpha beta squared minus alpha squared beta. And if you recall that beta is negative, you recognize this first quantity in parentheses will be a negative number, and we'll get a negative time. Therefore, we want to take the negative of this and not the positive value. And so that we expect t2 to be equal to alpha minus beta times the square root of 2s over 3 alpha beta squared minus alpha squared beta. And of course you'll want to check this. One way to do that is to look at special cases where you know what the answer should be. For example, if the magnitude of alpha and beta are equal, then the amount of time it takes to get then that changeover point will be halfway along the track between the two. And so you can plug in and use 1/2 at squared to be half the distance when you put in a time that's equal to 1/2 of t2. And you should come up with an expression that matches this. Okay?